We know the speed of light. Not approximately, not as a best estimate subject to revision. We know it with the kind of precision that makes other physical measurements look like guesses scratched in sand. In a vacuum, light travels at exactly 299,792,458 meters per second. This number is not merely a measurement. Since 1983, it has been a definition. The meter is officially defined as the distance light travels in 299,792,458 of a second, which means the speed of light and the meter are mathematically locked together in a tight relationship so fundamental that you cannot question one without dismantling the other. Built on top of this number, constructed with the same precision and the same finality, is special relativity. Einstein published it in 1905, and in the century since, every single prediction it has made has been confirmed. Time dilation is real and measurable. Length contraction is real and measurable. The equivalence of mass and energy is real and has been confirmed in every nuclear reaction ever observed. GPS satellites require relativistic corrections to function accurately. Particle accelerators are engineered around relativistic mathematics. The speed of light as an absolute universal speed limit is not a hypothesis awaiting confirmation. It is the most thoroughly tested and confirmed principle in the history of physics. Nothing has ever been observed traveling faster than light. Nothing. Not once. Not even close. And then there is the causality violation. It is the first and most devastating consequence of faster-than-light travel, and it arrives not as a dramatic explosion, but as a quiet logical collapse. Special relativity does not merely prohibit faster-than-light travel as an engineering inconvenience. It prohibits it because faster-than-light travel is mathematically equivalent to time travel into the past. This equivalence is not a metaphor or an approximation. It is a precise consequence of the Lorentz transformation, the mathematical framework at the heart of special relativity. If you can send a signal or a particle or a person faster than light in one reference frame, then you are faster than light. Then there exists another perfectly valid reference frame, moving at a velocity below the speed of light and therefore entirely permitted by physics, in which that signal arrives before it was sent. The cause comes after the effect. The reply arrives before the question was asked. The bullet strikes the target before the trigger is pulled. This is not a paradox that physicists have found a clever way around. It is a hard mathematical consequence of the structure of spacetime that has no resolution within special relativity. Faster-than-light travel does not merely break causality in exotic edge cases. It breaks it universally and immediately, in every reference frame simultaneously, the moment the first faster-than-light signal is transmitted. The entire logical architecture of physics, every equation that describes how one state of a system evolves into the next, every law of cause and effect that has ever been written down, rests on the assumption that causes precede effects. Faster-than-light travel does not merely challenge this assumption. It destroys it completely and leaves nothing coherent in its place. The second way physics breaks is the information paradox it creates. One of the most foundational principles of quantum mechanics is that information is conserved. It cannot be created from nothing, and it cannot be destroyed. The unitarity of quantum mechanical evolution, the mathematical property that ensures the total probability of all possible outcomes always sums to 1, is the formal expression of this principle. Every quantum computation, every measurement, every physical process preserves the total information content of the system it involves. Hawking radiation and its implied destruction of information inside black holes is considered so catastrophically problematic that resolving it has occupied some of the best theoretical physicists alive for decades. But faster-than-light travel does not merely threaten to destroy information. It threatens to allow information to be received before it exists. A message sent faster than light in a causality-violating trajectory could, in principle, arrive at its destination before the events it describes have occurred. The information content of the message would exist in the universe before its physical reference. Quantum mechanics has no framework for this. The wave function, the mathematical object that encodes all information about a quantum system, evolves forward in time according to the Schrödinger equation. It has no mechanism for backwards information propagation. Faster-than-light information transfer would require a complete rewriting of quantum mechanics from its foundations, and any replacement theory would need to explain why information conservation appears to hold perfectly in every experiment ever conducted at every energy scale ever tested. The third rupture is in thermodynamics. The second law of thermodynamics states that the entropy of a closed system never decreases. Disorder increases. Heat flows from hot to cold. The arrow of time points in the direction of increasing entropy. This law is not merely an empirical observation, though it is confirmed by every thermodynamic measurement ever taken. It is deeply connected to the statistical behavior of large numbers of particles, to the asymmetry between past and future, and to the fundamental directionality of physical processes. Faster than light travel, by enabling access to events in the past light cone of the traveler, creates scenarios in which entropy could decrease. An observer with a faster-than-light ship could, in principle, travel to a moment before a high-entropy state existed, observe it, and return. The thermodynamic arrow of time is not merely a practical observation. It is woven into the structure of statistical mechanics and quantum field theory in ways that cannot be cleanly separated from the rest of physics. Introducing faster-than-light travel into this framework does not create a minor inconsistency. It unravels the statistical foundations of thermodynamics by making the direction of time a matter of choice for sufficiently fast travelers rather than a fixed property of physical law. The fourth collapse involves quantum field theory. This is the theoretical framework that combines quantum mechanics with special relativity and forms the basis of the standard model of particle physics. Our deepest and most precise description of the fundamental constituents of matter and their interactions. Quantum field theory is built on special relativity in an absolutely non-negotiable way. The requirement that physical laws be the same for all observers moving at constant velocity, which is the foundation of special relativity, is encoded into quantum field theory through the mathematical structure of its fields and the way they transform under Lorentz transformations. One of the most important theorems in quantum field theory is the CPT theorem, which states that the combined operation of charge conjugation, parity transformation, and time reversal is an exact symmetry of any Lorentz invariant quantum field theory. This theorem, and the entire mathematical structure it represents, requires Lorentz invariance, which requires the speed of light to be an absolute limit. Faster-than-light travel would not merely be inconsistent with quantum field theory. It would require abandoning Lorentz invariance entirely, which would require rebuilding quantum field theory from scratch, which would invalidate the theoretical foundations of every prediction the Standard Model has ever made. The Standard Model predicts the magnetic moment of the electron to 12 decimal places. Its predictions have been confirmed in thousands of independent experiments. Abandoning Lorentz invariance to accommodate faster-than-light travel means explaining why all of those predictions were right for the wrong reasons. The fifth fracture is the tachyon problem. Physicists have considered the possibility of particles that always travel faster than light, called tachyons, for decades. Unlike ordinary particles, which cannot be accelerated to the speed of light, tachyons would always travel faster than light and could not slow down to it. The mathematics of tachyons within special relativity produces imaginary mass, a mass value that is the square root of a negative number. This is not merely an unusual mathematical result. In quantum field theory, a particle with imaginary mass indicates a vacuum instability. The vacuum state of the theory is not at its lowest energy configuration. The system is sitting at a local maximum of its potential energy, like a ball balanced on top of a hill, and will spontaneously decay to a lower energy state. Tachyonic fields appear in string theory and in the Higgs mechanism, but in both cases, they signal an unstable starting point that the theory evolves away from, not a stable particle that can carry information. Every attempt to construct a consistent quantum field theory containing tachyons that can transmit information has failed. The mathematics consistently produces either causality violations or vacuum instabilities or both. The tachyon is not a particle waiting to be discovered. It is a mathematical indicator of a broken theory. The sixth devastation is gravitational. General relativity, Einstein's theory of gravity, describes spacetime as a dynamic geometric structure that curves in response to mass and energy. It is the most precisely tested theory of gravity ever constructed. Its predictions of gravitational waves, the precession of Mercury's orbit, the deflection of light by massive objects, the gravitational redshift of photons, and the existence and behavior of black holes have all been confirmed with extraordinary precision. Faster-than-light travel requires either that objects can move through spacetime faster than light, which special relativity prohibits, or that spacetime itself can be manipulated to effectively move objects faster than light, as in the Alcubierre warp drive proposal. The Alcubierre metric is a genuine solution to Einstein's field equations. But maintaining the warp bubble requires exotic matter with negative energy density, and the energy requirements, depending on the specific parameters of the bubble, range from the mass and energy equivalent of a planet to the mass and energy equivalent of the observable universe. No exotic matter with negative energy density has ever been observed. The Casimir effect produces regions of reduced energy density between closely spaced conducting plates. But the energy involved is many orders of magnitude too small, and the geometry is entirely wrong for maintaining a warp bubble. Furthermore, recent theoretical analysis has shown that the interior of an Alcubierre bubble is causally disconnected from its walls, meaning the traveler inside cannot steer or control the bubble once it is moving. The warp drive solves no problem that it does not immediately replace with a worse one. The seventh breakdown is in quantum entanglement. Quantum entanglement is frequently misunderstood as a mechanism for faster-than-light communication, and the misunderstanding is persistent enough that it deserves direct address. Entangled particles do exhibit correlations that appear instantaneous regardless of the distance separating them. When the spin of one particle in an entangled pair is measured, the spin of its partner is immediately determined, no matter how far away the partner is. This has been experimentally confirmed over distances of hundreds of kilometers. But this correlation cannot be used to transmit information. The outcome of each measurement is random. The observer measuring the first particle gets a random result. The observer measuring the second particle gets a random result. The results are correlated, but neither observer can control what result they get, which means neither can encode a message in the correlation. The no communication theorem, a rigorous mathematical result in quantum information theory, proves that quantum entanglement cannot transmit information faster than light under any circumstances within standard quantum mechanics. Attempts to use entanglement for faster than light communication have all failed, and the failure is not technological but mathematical. Any extension of quantum mechanics that allowed faster-than-light signaling through entanglement would be inconsistent with special relativity and would reintroduce all of the causality violations already described. The eighth collapse involves the relativistic mass increase. As an object accelerates toward the speed of light, its relativistic momentum increases without bound. The energy required to accelerate a massive object approaches infinity as its velocity approaches the speed of light asymptotically. This is not an engineering problem. It is not a matter of building more powerful engines. It is a fundamental mathematical property of the relationship between velocity, mass, and energy in special relativity. To actually reach the speed of light, a massive object would require infinite energy. To exceed it would require more than infinite energy. A concept that has no physical meaning. Every particle accelerator ever built has confirmed this relationship. The electrons and protons accelerated in the Large Hadron Collider reach 9,999,991% of the speed of light. The energy required to push them from that velocity to the speed of light itself, let alone past it, is not merely large. It is mathematically undefined. The relativistic mass increase is not a barrier waiting for clever engineering. It is the structure of spacetime expressing, in the clearest possible mathematical terms, that the speed of light is not a limit that can be approached from both sides. The ninth fracture is in the principle of relativity itself. Einstein's special relativity rests on two postulates. The first is that the laws of physics are the same for all observers in uniform motion. The second is that the speed of light is the same for all observers, regardless of the motion of the source. These two postulates together, and nothing more, produce all of special relativity, including time dilation, length contraction, and the impossibility of faster-than-light travel. The first postulate is not merely an assumption Einstein made. It is a statement about the symmetry structure of the universe that has been confirmed by every precision experiment ever conducted, including searches for violations of Lorentz invariance at extremely high energies using cosmic ray data. If faster-than-light travel is possible, one of these two postulates must be wrong. If the first postulate is wrong, different observers in uniform motion experience different laws of physics, which would have been detected in precision tests of Lorentz invariance. None have ever been found. If the second postulate is wrong, the speed of light is not constant for all observers, which would invalidate the entire framework of electromagnetism, since the constancy of the speed of light is a direct consequence of Maxwell's equations, which have been confirmed to extraordinary precision in every application from radio transmission to fiber optics to the functioning of every electronic device ever made. The 10th rupture is cosmological. The observable universe has an edge. Not a physical boundary with something beyond it, but a horizon defined by the speed of light and the age of the universe. Light from regions beyond this horizon has not had time to reach us since the Big Bang. The universe may be infinite or it may be finite, but the observable universe is the region from which light could have reached us in 13.8 billion years, and it has a radius of approximately 46 billion light-years. If faster than light travel is possible, this horizon ceases to have physical significance. Information and matter could in principle have reached us from arbitrarily distant regions of the universe regardless of the speed of light. The entire framework of modern cosmology, the inflationary model, the cosmic microwave background radiation, and what it tells us about the early universe, the large-scale structure of galaxies, and what it reveals about dark matter and dark energy, all of this is built on the assumption that the speed of light is the maximum rate of information propagation. A faster-than-light universe is not a universe in which cosmology becomes harder. It is a universe in which the cosmological observations we have made cease to have the meaning we have assigned them. The 11th and final way physics breaks is the deepest and the quietest. It has no dramatic name and no famous associated paradox. It is simply this: physics is a description of relationships. Every equation in physics describes how one physical quantity relates to another. The speed of light appears in those equations not merely as a constant but as a structural element, woven into the mathematical fabric connecting space and time, energy and mass, electricity and magnetism, quantum mechanics and gravity. It is not a number that happens to be large. It is the conversion factor between space and time, between mass and energy, between the electromagnetic and the mechanical. Remove it, alter it, make it negotiable, and the equations do not merely become harder to solve. They become structurally incoherent. The symbols retain their shapes, but the relationships they describe dissolve. You are not left with a physics in which faster than light travel is permitted. You are left with a collection of symbols that no longer refer to anything real, arranged in patterns that no longer constrain anything physical, describing a universe that follows no consistent rules at all. And perhaps that is the most terrifying implication of everything in this framework. Not that faster than light travel is dangerous or paradoxical or technically impossible, but that its impossibility is not a limitation imposed on a universe that could have been otherwise. It is the shape of the universe itself, expressed in mathematics, and the mathematics is telling us, in terms as clear and final as anything science has ever produced, that the structure of reality is not a cage we are trapped inside. It is the only coherent thing there is, and there is nothing beyond it to escape to, and the silence on the other side of the speed of light is not an unexplored frontier. It is the place where meaning ends.